I'm going to talk about intelligence. My starting point is epistemology. That's the field of philosophy which deals with knowledge. Like, how do you learn? How do you create knowledge? Which are the same question. And how do you evaluate ideas to decide which are the good ones, which are the bad ones, what's true, what's false? So, what's distinctive about intelligence? What is the hallmark of it? How do you tell if something's intelligent or not? And to keep it simple, I'm going to try to just start with humans and look at what humans are like. So the defining feature of humans is that they're able to learn things. They can invent new science, new technologies. They can write poems. They have creative thought. They're able to take problems and figure out, all right, what's the solution? Not every time, but a lot of the time, they figure out solutions to all kinds of problems. So there's a very, powerful, important ability there, which we call intelligence. This ability to think in productive, effective ways about the world and figure things out and figure out how to make good choices and good decisions and plan ahead and all kinds of stuff like that. So the underlying theme of all of that is knowledge. It is creating knowledge. What are the right questions? That is knowledge. If you have the questions, that's a type of knowledge. If you have the answers, that's a type of knowledge. Understanding what the problems are or what the situation is, that's knowledge. Understanding the solutions or the right actions to take or the right decisions to make, more knowledge. All of that is knowledge. Knowledge is a very broad thing. What is knowledge? It's, in short, useful information. Because the world is full of information. That tree is 6 feet tall. That tree is 8 feet tall. That tree is 20 feet tall. But it's like most of the information, who cares? Most of it's not relevant, not useful. Actually, writing it down would even be a waste of time. There's too much information in the world to just write it all down and hope it'll be useful. There's actually a nice joke about that. This guy spent his whole life observing things and writing them down and documenting them. And then he hands it to the Royal Society and says, "Here you go. I've observed a lot. You guys figure out the implications, but the data should be very useful, right?" Well, no, you have to be selective about your data gathering. You have to figure out what would be a useful experiment to do, or what's a good area for study. Anything you observe, like there's many different things you could write down about it. You need some sort of idea of what you're looking for to know which things might be relevant. Okay, so information is just like the generic term for any sort of data. And then knowledge is the actual useful data, the good ideas. So that's what humans are able to create. Like, we don't just create arbitrary information. We don't just write down piles of data. We actually, figure out useful things, solve problems. We're able to be selective about judging what's important and what's not important. Okay, so now if you look at this from the perspective of epistemology, you can look at fundamental questions. So before you can actually understand intelligence very well, you need to think a bit about knowledge. So starting with basically, how can knowledge be created? What processes can create knowledge? What methods can actually create it and what can't? So this is one of the most important problems in the field. You might think it would be like a simple question or an easy one, because it is a simple question, but it's not an easy one. It's a question that has thousands of years of thought has gone into it, and it's quite a difficult question. And it turns out it's really difficult to come up with any answers whatsoever. Like, it's hard to think of how it could possibly be possible to create knowledge. So it's sort of a get stuck at the very beginning kind of question, where people are like, well, that's quite a stumper. I don't know. That's what most of the thought has really been like, is people just don't know the answer. It's really tough. Okay, so that actually provides this really important context to the intelligence question, because human intelligence has something to do with creating knowledge, and what processes can create knowledge is a very old and very, very difficult question. So what we should do is look at what's actually known about this question. It's a hard one, but there has been some progress made on it. So what do we know? And then once we figure that out, once we look at what we know about the key question, then we can apply it to intelligence and say, okay, what does that imply about what ways intelligence could possibly work or not? Because it has to work according to a way that could create knowledge rather than a way that could not create knowledge. So that'll put some limits on what ways intelligence can and can't work. It'll give us some ability to model it and rule out some models. This is not the usual approach because I'm not starting with science. I'm not starting with looking at brains under microscopes or something like that. I'm not starting with MRIs and like ask people questions and then see which areas of their brain have activity or something. You know, those approaches, there is some value in those kind of things, but you have to have the right like framework and way of understanding and looking at the issue, and then you can start to fit those more specific details into the bigger picture. But you need some sort of coherent bigger picture, or at least like a frame of one with a lot of pieces missing to give you some idea of what you're looking at, so you can figure out what's relevant or not and what would be good details to try to fill in, and then which science might help us fill them in. So people sort of start in the middle, and that's a big error. So I want to start with like the actual fundamental questions. And another thing is I don't want to do a ton of complexity. So people just sort of give up and say, oh, it's so hard. And not just hard, but like so much complexity. You have to like read 1 million books. There's 1 million academic papers about it, 1 million experiments. There's just so much to know. They think it's sort of overwhelming with all this information, and that you'd have to be like a specialist who devotes their whole career to it to actually figure much out. And I don't agree with that. I think that inventing this stuff in the first place maybe takes a specialist, and you have to, you know, put your career into it and try and figure things out. It's hard. And that's something I've put a lot of effort into, and a few other people like David Deutsch and Karl Popper have. But the results of all that effort and research is not this huge mess of complexity. It's not, oh, well, you'll have to read every single book to understand a word of it. It's, you know, we've actually come up with some conclusions that we can explain in reasonably simple ways. Even if like inventing it in the first place is harder, once you understand it, then you can look for ways to simplify it and ways to make it intuitive and make sense to people. And you can talk about that, and there's a lot of value there. So I'm going to try to do some of that instead of just saying, oh, you're not an expert, so trust me, which I think is a really bad approach. That people don't usually say it that blatantly, that bluntly, but there's a lot of that kind of attitude in the world. Okay, so how can knowledge possibly be created? To understand this, it helps to look at a lot of the history of this problem and some related problems that are actually very similar. So one of the problems is, where does the eye of an animal or a human come from? So an eye is a complex thing which has the appearance of design. Whether or not it's designed, like it has at least the appearance of it, like it's the kind of thing a designer would design. It's functional, it fits its purpose really well. It does this complicated thing. It's not random, right? An eye is not just a thing that like, oh, the molecules just happen to fall into that configuration. That's not an adequate explanation of an eye. That is an adequate explanation of a rock. It's like, why is this rock this shape instead of another shape? You know, you can just say, oh, well, that was random, like the weather did it, whatever. You know, it doesn't require a special explanation. Or it's like, how many grains of sand are on the beach? Why is it like 1 million instead of 1,000,001? You don't need a special explanation for that. It's not that interesting of a problem. But why is the eye this particular way? Or why do birds have wings instead of just, you know, random feathers scattered around? How did that get created? So the underlying thing here is this appearance of design, this complexity for a purpose, this purposefulness of the things in reality is the hallmark of knowledge. That's, whenever you see that, there's knowledge there. And the actual thing you're asking about is, how does knowledge get created? You know, an eye contains knowledge. It contains not just information and not just randomness, but actually useful information for a purpose, to solve a problem. So how did that get there? So now that I've related it to this problem, some of you may have some clue where I'm going with this. because the solution to where the I comes from is evolution. And there are only a small number of alternative theories because it's a very hard problem, like of how the origin of eyes or various other adaptations that animals have. A lot of people have tried to come up with answers to that, but there aren't very many. Evolution is one of them, and there's a few others. There's God did it. There's various attacks on reality, it's all just a dream or something. You can go in that kind of direction. You can say there is no truth, so everything you're saying is nonsense. There's very silly directions. But as far as actual answers go, it's mostly just sort of God did it. There was an intelligent designer that designed it. But the problem with that answer is, where did God come from? Then God is a complex thing. God has knowledge. Where does God's knowledge come from? How did God create knowledge or get created in the first place with knowledge inside himself? So that the God answer doesn't actually help with the problem. It just moves the goalpost. It says, we're going to explain this purposeful complexity by positing some other purposeful complexity. It's okay, but then where did that purposeful complexity come from? You still have an equally difficult problem, if not worse. So God's a very unsatisfactory answer. But, what else could there be? It was a really hard problem. So evolution was a really genius answer, and there's basically no alternatives to evolution. There's no other concept of how this could be possible. Evolution is the one and only good answer we've ever come up with in the whole entire history of humanity for how can knowledge be created from non-knowledge? Where can knowledge actually come from? How can it originate? Now, evolution is something most people think they understand, but they don't actually know much about. So that makes this a little more complicated. Evolution is a theory in epistemology, not in biology. It is an abstract theory about replicators. Replicators are things that can make copies, they can replicate. And what evolution says is, as basically a matter of logic, if you make a bunch of copies of something, and there's some variation, some random variation, but the variations are pretty small, and then there's a selection process that selects the good variants over the bad ones, and you keep repeating this in a cycle, then you can evolve knowledge which meets the selection criteria, which is designed for the purpose of doing whatever the selection is. The application of this theory of replicators and this inherent logical idea to biology and the history of animals is one application, but it is actually a philosophical idea about how knowledge can be created, not just a specific scientific idea about animals. That's the most important content of it, is the actual idea, the concept that answered this really fundamental question, which is a broader question than just, how did the eye get created? How did a wing get created? Those are great questions, but there are other questions just like them. How did Atlas Shrugged get created? How did any good book get created? How were the ideas thought of? How do scientists make progress? How did we invent new medicines? How did we figure out which medicines work and don't work? It's not random. We're doing some sort of purposeful knowledge creation here. More analogously, how did we design cameras? We sort of created our own mechanical eyes in the form of cameras. Those are pretty cool, and they took a serious design effort, an intelligent thought process that could create knowledge. Similar to the eye took a design process, some sort of ongoing thing that was able to build up and create all the complexity and in an effective way. Well, cameras are also complex, and we also use some sort of process to build them up and figure out how to make them work and so on. So how did we do that? People usually don't give this much thought because it goes something like this. They think biological evolution created humans, and that's where our knowledge comes from. and then there's no mystery after that. It gave us our brain, and then the answer to cameras is they were created by an intelligent designer, a human being, and the intelligent designer was created by biological evolution, so that's the origin. So it's not like the God answer, because we actually have how humans were created in the first place. So that's not terrible thinking, but it's not good enough. We can do better than that. So we have to think about, like, how does the brain work? And in particular, did biological evolution create knowledge of cameras? No, it did not. Our genes did not evolve to tell us how to build cameras. That's not a thing that happened. There wasn't selection pressure for that. So our genes gave us a brain, but then somehow we used it to create new knowledge that our genes did not create. So genetic evolution is not the source of cameras. But the actual theory is genetic evolution gave us intelligence, and intelligence is the source of cameras. Okay, that's not wrong, but what is intelligence? It's somehow we can create knowledge. Well, how do we do it? Intelligence is a thing that our genes gave us, but how does it work? What did they give us exactly? So this leads exactly to the same problem. How can knowledge be created? Our genes gave us this capability to create knowledge. Like, I agree that they evolved it and now we have it. But how does it work? You can't just say, oh, well, we're intelligent. It works by intelligence. That's circular. That's a non-answer. So, and then going back to what I was saying earlier, this is a very hard problem that has been looked at a lot, and there's only one good answer that anyone has ever thought of, and that's evolution. So that is my answer to the problem. How does intelligence work? By evolution. This is not an analogy or a metaphor. This is 100% literal. Evolution inside human brains is how they create knowledge. There has to be replication with variation and selection of something inside of human brains, and that's how they're able to do intelligent thinking, and that's how they're able to design cameras and write philosophy books and so on and so forth. In other words, create new knowledge, create purposeful information that actually solves problems and is effective, and so on. Create design rather than randomness or non-selective accumulation of data. So what replicates inside a human brain in order for there to be evolution? With biological evolution, the thing that replicates is the gene. And we know a bit about it, like that genes are DNA sequences. So what's going on in the brain or the mind for evolution there? In some way, there are ideas being replicated, which we could call memes. And that's the basic outline of how human intelligence works. There is replication of ideas in our brain, so basically brainstorming, making a bunch of guesses. Because it's not just replication like exact copies, there has to be variation. And the variation has to be within some limits, so it's like somewhat related to the previous generation of ideas. And that's sort of what brainstorming is. Brainstorming has more variation than you see with genetic mutations. But, okay, first of all, that can be misleading because what we're talking about is conscious brainstorming. But most of our thinking, most of our knowledge creation happens at an unconscious level. And our conscious mind is like we focus in on a fraction of our thinking. So at some sort of lower level, there might be less variation with the brainstorming. But we don't need to get into like the fine details. So there's some sort of brainstorming, some guessing, some creating a bunch of ideas and making new versions of them. And then there has to be selection. There has to be criticism. There has to be ruling out the bad ideas. There has to be some way of picking which ideas survive, at least for now, and which ideas do not survive. So those are the basic components of the intelligent mind. Some sort of idea generator and some sort of idea selector. So two basic components. or you could conceive of it as three components. That's also an option. You could say it's an idea copier that makes exact copies, plus an idea varier that makes that turns the copies into different versions, plus a selector, a criticizer, a thing that decides which ideas survive or not. And all of this has to be very flexible because we do things like invent new problems. We come up with some sort of life goal or project or whatever that we want to succeed at, and then we're able to criticize ideas in terms of this goal. That is, we can create knowledge for this particular goal. So we can, in some way, configure our guesses to try to make them relevant to what we're doing. We can make them fit our purpose. And then we can also configure our selection, our criticism, our killing off some ideas and not killing off others. Also, we can configure that to fit our purpose, to fit our goal in some way, which is pretty clear consciously. We can do directed criticism. Like we can brainstorm ideas and then write them all down as a list and then criticize which ones will accomplish the goal and which ones won't. Like we can consciously go through that process. But we also have to be doing something sort of along those lines unconsciously because our conscious experience does not account for all of our intelligent action and thinking and so on. We're more powerful than what we manage to look at consciously. So this gives us a sort of outline of the mind. It tells us in broad, general terms what sort of major parts it has. Now, if you look at what people in the field say, none of them are saying this. This is like an unknown idea somehow. And they're all saying things that are incompatible with it. They're saying we learn in some other way that is not evolution, and there's no actual explanation of how it could possibly work. As a logical matter, a matter of decisive arguments, none of the rivals can work. They do not provide an alternative theory to evolution. It's not just a matter of how good they are or quality, this one's a bit better than that model of the mind. It is either it has to work literally by evolution, or you need an alternative to evolution, or decisively you don't know what you're talking about and have no possible answer to how intelligence works. And the alternative to evolution thing is something they don't even talk about. They don't actually understand the problem in the first place, so they haven't even addressed it. So it's not that they've come up with an alternative to evolution. It's that they don't understand what they're trying to come up with at all. They're just working on the wrong problems. So that's where people go wrong. So once we have some sort of model of intelligence like this, we can start looking at its implications and try to see what use it might be. So, for example, we can look at animals and we can say, do animals seem to be designing new knowledge for a purpose that is not encoded for in their genes? Have we ever seen them do that? Do animals act like us or not? And the answer is no. There's no recorded data showing animals having intelligence in the create new knowledge type. Animals, the reason people are confused about this is animals have purposeful behavior. So people see the animal doing what looks like intelligent behavior. The animal acts in a designed way that makes sense. So they think the animal is intelligent. But that's incorrect. The animal's intelligence is in its genes. The genes evolved the knowledge. The genes are the source of the design and control the animal's behavior. That's where the knowledge is. So it's not the animal creating knowledge. It was biological evolution already created that knowledge in the past, and the animal is just enacting it. But with humans, we have something completely different, because humans create knowledge that was not in their genes. None of my blog posts were in my genes. Instead, my genes gave me the ability to create blog posts, the ability to make guesses and criticism and design writing for a purpose, which is not something animals can do. So there's a fundamental distinction. A lot of people are thinking that animals and humans differ by degree. Humans are smarter than animals rather than a different kind of thing. But that does not make sense. There's no actual philosophical framework that allows you to think that way, and it actually makes sense. There's no rival to evolution to enable that. And if you think about it in the evolutionary perspective, then you've got to come to the conclusions I'm talking about. So how come some people are smarter than other people? It looks like there are degrees of intelligence among humans, right? So that's a good question. And the answer is people's fundamental raw capabilities provided by the genes are the same, but some people use it in better ways and worse ways. People layer different ideas on top of their raw capabilities, different ways of making decisions, different approaches to problem solving, different approaches to learning. There's different schools of thought on how to learn, how to educate kids, and depending on what education you get, what you learn from it, what you take away from it, what methods of organizing your thinking you try to use, you're going to be more or less effective. So what we normally call degrees of intelligence is a separate issue than the thing I've been talking about of the ability to create new knowledge or not. So the word intelligence does double duty. On the one hand, there's, can you create intelligent knowledge? Are you capable of intelligent thought, yes or no? And then there's also, how good are you at using your intelligence? How effective are you at thinking about things and solving problems and designing things and inventing things and so on? Now, just because people's differences of how intelligent they seem are not set in stone in terms of hardware, just because they're learned methods, cultural, environmental, etc., does not mean that they're easy to change or, unimportant. That's a very common misconception, is people think, well, if it's genetic, that means it's really hard to change or impossible to change, set in stone, human nature, etc. And if it's not genetic, then it's just an idea. You can just change your mind whenever you want, no big deal. And if it was just an idea, then why wouldn't the dumb people just change their minds and be smart? So clearly it's not an idea. That's sort of a common thought process. But it's not a very good thought process. Ideas can be quite hard to change. People's minds are very complex software projects. So you may not know anything about the industry, but software is really hard. And the bigger the software project, the harder it gets, because you got a million different components of software that all have to work together. And you got tons and tons of software bugs. And that's why every single big software company has a lot of bugs and they have quality problems and not everything works all the time. Sometimes your computer crashes, sometimes the app doesn't work, sometimes you lose data. All these things go wrong with computers because it's really hard. So the really big complex computer systems have software issues. It's hard to organize tons and tons of knowledge and not have any problems. And when you got a really big, complicated software program, it's hard to change it without breaking something by accident. And, there's a lot of banks, for example, that have really old software that's really hard for them to update because it's hard to make a whole new thing to replace it with its own set of new bugs and problems. And it is hard to make any changes or updates to the old one because it's so complex and any change risks breaking something, and the banks really don't want to break something. So it's very hard for the banks. Anyways, human brains or minds or whatever are like that. They're like this really complex software project where you've built up years and years of thinking and ideas. And at this point, it's really hard to change. It has a lot of flaws in it. Any change you make could break all kinds of things. Replacing it's not an option. You can't just rewrite a new program to replace your mind. So that is why you can't just change your mind just because intelligence has to do with ideas and degree of intelligence has to do with ideas and how you approach things, your learning methods, and so on. It is possible to change methods, but it's quite hard. It is like taking a very, very complex software project and then making a bunch of big changes to it, not out of the question, but quite difficult, easy to fail at. And our minds are, that analogy is not quite fair because our minds are much more complicated than any actual software projects. They're more advanced, they have more layers of abstraction, more hierarchical layers of building up complexity. Because the way software projects work and the way minds work and so on is you have like the simple beginning part, and then you build up some like slightly more advanced stuff on top of that as another layer of abstraction or a layer of higher complexity, higher level, more advanced stuff. And then on top of that, you build the next layer. And then on top of that, the next layer. And human minds have hundreds of layers of bit more complexity, bit more advanced stuff built on top of the previous layer. And our conscious mind, the vast majority of the time, only pays attention to the top layers, the ones near the top. And we have all this thinking going on at the lower layers that we're not consciously aware of, and it's really hard for us to change, but it actually has a big effect on our degree of intelligence, how clever we are, how good at science we are, and so on. Because if you make a bunch of mistakes at the lower level stuff, if you built up your complexity in the wrong way during childhood, then you're not going to be as good at thinking, you're not going to be as effective at using your intelligence because you're making all those mistakes over and over every time. So that stuff is difficult, and having a reasonable perspective on it is at least a starting point to think about how we might improve it or help people or make some sort of intervention. But I want to be very clear that just because it's a software problem instead of a hardware problem, memes instead of genes, does not mean being dumb is your own fault and you can just change your mind. It's more like a thing that got developed in early childhood and no one knows how to change their minds about a lot of it very effectively or reliably. Like sometimes people manage to change stuff, but a lot of times they don't, and it's not very repeatable, and no one really knows how to guide someone to do it very well. So like there's hope, but it's difficult. It's not automatic. So the sort of standard model people have of ideas as being lightweight, easy to change your mind, etc., is completely wrong. It would be better to think of ideas as more complicated and heavyweight and than a major software project. A worse mess to deal with than like the worst giant software projects in the world is what a human mind should be thought of as like. You might think at that point that like it's a miracle that people like think at all and are able to function in life and so on. And how can that be possible when they have this whole mess and they had to make all these decisions in childhood when they were building up the earlier layers of complexity for how their mind works. And they don't know what they're doing when they're children. So how are people able to think like at all? How does that work? The short answer is tradition. So over, very long period of time, humanity has gotten slightly better at educating children and slightly better at what things are passed on to the next generation. There's been very gradual progress over generational timeframes on what to teach children and how to guide them through the early years. And I'm not saying we're very good at it, but it used to be worse, and we've gotten better enough that modern civilization is actually possible, so that's pretty good. So another implication of this way of thinking about the mind is that antidepressants don't work. So whether you're, quote, depressed is a high-level thing. It's near the top layer of abstraction or software complexity. It's near the surface. And antidepressants work near the bottom level, near the hardware level. So antidepressants are hundreds of layers of interlocking complexity, hundreds of different levels of abstraction, away from the actual things that they're supposed to control and affect. That's not the full argument, but you can get some sense that that would be very difficult to make them work. How are you going to tweak something and then have it go through like hundreds of interlocking gears, mechanisms, steps, whatever, and get the output you want at the end, you'd have to understand the whole fucking thing, understand all the complexity. If you understood every piece of it in detail, then sure, you could tweak something at one end, and you could get a predictable effect at the other end, to the extent that it's deterministic or, actually predictable. But if you don't understand all those layers in the middle, all the complexity of the human mind, then it's hopeless. If you don't understand, so you tweak something at a hardware level with some chemicals, and then, software layer 1 reads in that data and does some processing, and then software layer 2 reads the output of that and does some further processing, and software layer 3 takes the output of that and does some further processing. And, at some point it branches off and gets used for 20 different things, and it goes through literally, hundreds of layers of processing to interpret it and decide what to do with it and figure it out, and so on. And anyways, this is such a complex process that there's just, unless you understand the whole process, which we totally don't, no one does, we don't know all the details of it, then there's just no way to make hardware changes and expect them to actually work and come out right at the high level. Which is exactly what we see. Like, antidepressants are quite unreliable, and there's no actual good research that says they work at all, really. Like, there's blinding issues and other scholarship issues with the research, and there's major issues like with bias because of judging whether someone's depressed and whether they've recovered and so on is actually really hard to measure objectively and avoid any bias. You get problems like that, and the whole field's a mess. But anyways, the point is that antidepressants work at this completely different level than your conscious mind. And there's all these levels of software processing in between, this huge amount of complexity in between the two things. So to expect antidepressants to work is really weird. And the reason people expect it to work is they don't have this model of the mind. They don't see it as, oh, we're tweaking something that's 100 steps away from the thing we're trying to control. How are we going to get that to actually have the right outcome? Okay, so if we put our minds in computers, and we would have a chance at changing something at the bottom level and getting an outcome we want at the top level. How would we do that? We would set up automated tests, and we would do millions and millions of tests. We'd just try everything at the bottom level, see what happens at the top level, record it all, and try to look for some patterns or see if we randomly get the right thing. If each API level was in our computer and was responding in milliseconds, and we could just do millions of tests and it wouldn't have any effect on anyone's life, maybe we'd manage to figure it out. There's so much complexity, but the huge amount of testing might let us happen on a solution. But that's not at all what's happened with antidepressants. We've tested dozens of chemicals, maybe hundreds, not millions, not billions. We haven't tested an amount of stuff equal to the complexity of the problem. So happening to get a solution is very unlikely because we've tried so few things. And the response time when we try something with antidepressants is, let's optimistically call it a month instead of a second. So it makes it much, much harder to test anything. And you get a million confounding factors and uncontrolled variables that make it pretty much impossible to get a proper output because so many things are going on in a person's life all at once that it's really hard to tell if you make one change, was that the cause of the thing on the other end that came out? So we don't have a controlled environment where we can make a single change and see what changes. And we can't make millions of changes to have a decent shot at it. So it's completely unrealistic for antidepressants to work. So that's one of the things you can think about using once you have an actual model of how does the mind work, some way of thinking about it, some way to conceptualize it in terms of it has to work by evolution. We have brainstorming and criticism, and it has to work. And so it's this software program on top of the hardware, that we build up that is our thinking methods and so on top of that. Because just like brainstorm and criticize does not account for like all the complexity of our lives. We're using that method to learn like tons and tons of things, to learn ways of making decisions, ways of dealing with things, ways of problem solving, which we then go on to use. Another thing about it is that the method of evolution is a universal method. So the method of replicate, vary, and select works for learning anything. There's no type of knowledge that you couldn't get with that. So people normally conceptualize it as like there's a bunch of different types of intelligence and they can each learn different things and people have different capabilities. And that's all wrong. It is this one fully generic method that can do anything. There's no like inherent limit. Like what can you not guess? What could brainstorming not think of? You know? It's not like brainstorming only works in science, but you can't brainstorm stuff about art. There's no limit like that. And if you think of it in like more detailed terms as like information theory, it's like, well, we're brainstorming information. There's no limits on like what bit strings or information we could brainstorm. It's this anything. There's like literally any piece of information is a thing we could brainstorm. I mean, maybe you get into length limits, like maybe we can't fit like 1,000,000 gigabytes in our head, but you know, that's what we use tools for. Get some hard disks and whatever. But yeah, dealing with like really, really, really long, big things is problematic. But if you stick to like short, small ideas, then it's sort of like English is like a universal language in various ways. Like you can make any sentence, like if you understand how to like write a sentence, you can write like, you can put whatever words you want. There's no limits where it's like you can't put certain words in certain orders or something so that you'd like be unable to write about certain topics. You know, it's just this generic thing where you can write about whatever you want. You can arrange the tools in whatever way, or the words. There's more advanced arguments about this. If you read The Beginning of Infinity by David Deutsch, it talks about universality and the jump to universality. And so you can make arguments that there's no like 90% repertoire knowledge creator device. That's not like a thing in the same way that there's no 90% repertoire computer. You know, computers go from this is well known in the field of computers. You go from like a very primitive, limited computer that basically has no features, can't do anything, is basically worthless, pretty much reasonably close to worthless. Nothing at all like your iPhone or whatever. And then it goes straight from there. You add one more feature and it can compute anything that can be computed. Well, intelligence works the same way. You take, brainstorming without selection and you've got nothing. You take selection without brainstorming and you've got nothing, but you put both together and then suddenly you have everything. There isn't like a middle ground of like 70% intelligent in terms of capabilities. There is a middle ground in terms of how well you use your intelligence, like, you know, how well you understand reason and use reason in your thinking has a middle ground. So other implications here are about the role of genes in biology in our lives and how limited it is. Our lives are mostly about our minds, our use of reason, our ideas, our opinions, our values, our decision making. Because we have this capability to create new knowledge that's not in our genes, and we use it a lot, and we create tons and tons of complexity in our minds on top of whatever was in our genes. We do tons and tons of evolution on top of the biological evolution that happened in the past, and it creates all this new stuff in our lives, which is what sets us apart from the animals, and is why our lives look so different than animals, which shows you that there's like a lot of it. A more primitive man, there used to be less of it, and they would live more like animals, and you know, there's less difference there. And the more complex civilization has gotten, the more complex education has gotten, the more complex our civilization's knowledge that we've been passing on to the next generation has gotten, then the further apart from animals we are, because we're using our special capability that animals don't have. The more we use it, the more we're going to be noticeably different from animals. and the more our genes and biology will play a small role in our lives because this other thing is playing a bigger role. So this has lots of implications for the nature-nurture debate, where basically no one talks about the mind as a very, very complex software project that's hard to change. So stuff is culture and ideas, but they're actually really, really hard to change. That's not one of the things on the table. The two competing positions are it's human nature, it's genetic, blah, 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 or the social constructionist point of view, the like, oh, society can just mold people into whatever it wants kind of point of view that thinks everything's really easy to change. And, those are both totally wrong. It's like this massively complex software project that's really hard to change is the right model. So not nature or nurture in terms of the naive views, but, effectively it's nurture. It's what happens during your life, what software you build up on top of your hardware capability that lets you create knowledge that everyone has. And if you look at intelligence, okay, so people want to make all sorts of excuses for how hardware capabilities determine how smart people are. So that they come up with stuff like, well, I see that, we could both conjecture or brainstorm anything. So like that's equivalent. And how we configure our selection process, our criticism, is, maybe they both can be configured in any way. It's totally flexible. So we both have the same capability there. However, maybe I'm born faster at brainstorming than you. Or maybe I can have more ideas in my head at the same time and remember them. Maybe I have better memory. Or maybe my long-term memory has a lower error rate than yours. You can come up with some stuff where hardware can make some sort of difference, but basically this does not account for the differences we see between people in large part. So the difference between like the smart person and the dumb person is not the dumb person needs an hour when the smart person needs 10 minutes, and then the dumb person makes an equally good decision. It's not just he's doing the same thing slower, Dumb people often are thinking really fast. So maybe one person's faster at thinking and they both use the same amount of time, so then the faster hardware wins. It's like, okay, that's possible, but why doesn't the dumb person just take his time more? There must be some mistaken conception of how to approach thinking where he doesn't give himself enough time to get a good answer. So that's a huge mistake, and it's not a hardware problem. And it's the same with all the other stuff. If you have a higher error rate memory, well, then you need more error correction, more checksums, more parity bits, whatever. More double checking, more redundancy, more like RAID arrays in your memory. Like, these are solvable problems that we have all sorts of software and hardware and technology solutions for. We know how to deal with things like error rates. And, internally in your mind, your complex software project at the unconscious level needs to be dealing with that kind of thing. And whether your early childhood you develop good or bad ways of dealing with it determines how effective your thinking is. Rather than the hardware itself, it's the layer on top of it that decides how to use the hardware. If that layer was dramatically better, you could be like the biggest genius in the world, even if you have the worst hardware, because the hardware differences aren't that fucking big. They're not the dominant factor here. And no one even really cares that much if you have a genius scientific breakthrough in like a day or a week or a month. Like it being at different amounts of time just doesn't matter that much. So you have time to like go slowly and not fuck it up if you actually knew how to do that. So even if your hardware was a bit slower and more inclined to fuck ups, it wouldn't matter if you were dealing with that appropriately. It's not entirely in your hands because there are lots of ways that our culture time pressures people. So to the extent that our culture puts a bunch of time pressure on children and doesn't let them approach things in a better way, then it makes hardware differences matter more. So certainly some of the ways we treat people bring out hardware differences in some ways. I don't think that's like a huge factor, but it makes some difference, sure. But that's not exactly nature, is it? It's our culture is making certain things be emphasized in ways they don't need to be. So if we change the culture, we could change the outcome. It's hard to change. It's subtle. There's all sorts of problems with changing it, but it's, in theory, change the culture, change the outcome. What sets smart people apart primarily is they come up with new ideas and they come up with more correct ideas and decisions and whatever. So those are not hardware features. Any connection of those things that we really highly value to hardware is through many, many different layers of software complexity and abstraction. And you can think of it as like different layers of APIs. Like you have 100 different APIs, and each API talks to the next one until you get to the conscious mind at the top. And the things that you care about don't even exist at the lower level APIs, which is why antidepressants can't directly deal with them. Or similarly, it's why alcohol cannot impose major personality changes on people, because personality doesn't even exist at the lower level where the alcohol is affecting anything. Personality is, it starts at API level 50. And then it gets developed into a more complex thing by level 100. And the alcohol is at level 0. And alcohol is a simple molecule that doesn't know a damn thing about human culture. So what's really going on there is people react to the alcohol. They are having a reaction, not a genetic hardware reaction, but a many, many complex layers of software is reacting. And they feel like it's hardware because they feel like it's out of their control. And that's because it's unconscious. It's not entirely unconscious, but a lot of it is unconscious. It's this overwhelmingly complex software project in their mind that they don't know how to deal with and get a grip on and modify in the ways they want to modify. And so they blame hardware because of the complexity, the difficulty of change, the overwhelmingness, the feeling of being helpless and not being able to control it and all that. But those are absolutely features of hardware projects. Of software projects. Those are absolutely things that come up in actual software development. So they do not indicate hardware, and hardware doesn't actually make a lot of sense for most of the issues. So final sort of topic. How do I know I'm right about all this? Maybe there's a bunch of smart people who know a bunch of stuff I don't know and I haven't read it, and maybe they know why I'm wrong and blah, blah, blah. So what's the sort of world status of these ideas? They're largely unknown. They're developed primarily by me and David Deutsch, and they build on Karl Popper's epistemology called critical rationalism. I have reading recommendations on the Fallible Ideas website. You click on books at the top, and because Popper has a lot of books and they're kind of hard to read, and so I actually went through and said which specific chapters of which books are really important and good. So you can read in a really targeted way. And if you add it all up, it's you read one book, except that it's split up between all these different books and it comes out a lot better. So I recommend that if you're interested. But anyways, so we build on Popper because he's the evolutionary epistemology guy who rejected induction, refuted induction, and had this big breakthrough about conjectures and refutations is the name of one of his books, which is the evolutionary method of guesses and criticism, as I call it, because they're less fancy words. But conjecture means guess, means brainstorming. Refutation means criticism, means selection. It's the same thing. Anyways, so Popper has been widely misunderstood and not addressed. There's actually a book of replies to his critics where he has 50 prestigious people write criticisms, and he answered all of them. And there do not exist refutations of Popper that say, I've read through all his replies to his critics, and here's one of the things none of the critics said, and I understand Popper's view, here's what Popper thinks, and here's why he's wrong. There aren't criticisms like that. All of the criticisms are repeats of the things that already got answered, and they focus on Popper's early book, The Logic of Scientific Discovery, which is harder to read, less organized, less complete, not as good at dealing with people's misconceptions, which is why Popper wrote later books. He fleshed things out, he added more stuff, he made it easier to understand, and he figured out what ways people are misunderstanding him, so he wrote a bunch of answers to that stuff. And then most of the criticism just ignores all that later work to solve that problem and focuses on the earlier book. And you don't see critics who are just actually understand his views in a thorough way. Not many people understand him. So that's sad, but that's the situation. And it leads to things like all these people in the cognitive sciences wasting a lot of their time because they have the wrong ways of thinking about the issues, the wrong framework to try to fit their research into. Because philosophy is relevant to them and they're neglecting it and leaving it to some philosophers. And philosophy is sadly not a very good field on the whole. Like, most philosophers are pretty bad at their jobs. Like, I might not be a fan of most cognitive scientists, but like, philosophy is a worse field. I don't want to attack scientists relative to philosophers. There are a lot of really fucking bad philosophers, which is why it has such a bad reputation. And a lot of people want to stay out of it. But you don't want to leave philosophy, the most important fundamental field, to the incompetence. You can't do that. It's actually a big deal, and you need to get it right. So it's not a skippable, neglectable thing. It needs some quality people in it. And so many quality people in other fields downstream of philosophy are wasting a lot of their careers because they're downstream of an incompetent field and they're not fixing it. And we need good people who actually, like Popper, who actually do a good job. And then we need that information actually get spread and applied to other things like intelligence and all sorts. There's tons of applications. Like it has a lot of applications for education and how to run schools better, for example, and how to be a better parent, which is a really big deal if you want to have like a rational society. And like, if you like fuck people up when they're like 5 years old and fuck with their mind and their reason, then, and you do this continuously for years, then, science is going to suffer as a downstream consequence, and philosophy is going to suffer as a downstream consequence, and all the fields are going to suffer. And so that sucks. Anyways, so what I'm saying is more unknown than controversial or denied. There's not much in the way of like actual rebuttals or anything. And to the extent there is, like I've answered it, I do Paths Forward, which you can read about on Fallible Ideas. Go to my Paths Forward essay. But I have an actual like approach to how I'm open to public criticism and how I've shared these ideas in public. And if anyone actually knows why I'm wrong, they can talk about it. And most academics just want to, publish papers to get tenure or something, and they don't care about having actual back and forth discussions and dealing with criticism and offering criticism in a serious, robust way. That's because like having a serious critical discussion is like a lot of work and steps and whatever. You have to, like, you're going to misunderstand each other for the first several back and forth, and you have to iterate over and over and have like goodwill and actually want to talk to each other. And most people just don't do that very much. It's very hard to find like decent discussion forums. And it's very easy to not know things if you avoid discussion, because you're just not going to hear about a lot of good ideas. You can't read everything yourself. You can't try like every philosopher yourself. So you need to get like, the way to like survey philosophers is you can like read some survey books, but also what you want to do is talk to people and see, okay, find an advocate of this philosopher, find an advocate of that philosopher. Here are like the short version of why it's good, and see if you can answer it. Do you have like the short answer of why they're wrong? And if you don't, look a little bit further and then, learn a little bit more, and then see if you have like an answer to it, why it's bad, or maybe you think it's good and you want to learn more. But anyways, you just keep going step by step, learn a little more, investigate a little more. But people don't do this very much, so it's not random that these ideas are neglected. And it's not just that they're unknown and people don't pay enough attention. Like, there's actual methodological problems. Like, people think they're too busy to deal with criticism, and people don't like. There's a lot of people who say Popper's wrong, but I ask them, have you written a refutation of Popper? No. All right, second question. Is there a refutation of Popper written by anyone that you will endorse, you will take personal responsibility for? You will say, this speaks for me. If it's wrong, I'm wrong. And which meets basic criteria, like the author has, demonstrated a really good understanding of Popper and has read the Popper's Replies to His Critics book and actually frames his criticism in a reasonable way. Like, here's a summary of Popper that's actually right. And, and tell us basic things like, was Popper right in his replies to his critics? Are you going to just say, Popper was right about all that, but I have a new and different criticism? Or are you going to say Popper missed the point of one of the criticisms? Like, just give us some basic framing of what you're talking about and engage with the actual discussion that already exists. And, this is not like a high bar, really. You just have to like read a few books and engage with the literature, and you can try to say why Popper's wrong if you think he is. There's actually quite a lack of people who actually know much about him. I think he's wrong. Anyway, finally, to sum up, one of the things I really hope this got across is the ability for like reasonably simple thinking to have big consequences and conclusions. Like, it can be hard to come up with a simple version, but I already did some of that work for you, so you can judge this for yourself. You don't just have to decide which expert you're going to believe. You don't have to decide, does Eliot have better credentials than Pinker or whoever else? My hope is that you can see if what I was saying makes sense to you, and if it does, maybe you can learn more about it and tell it to people and share it and spread the word. And if it does not make sense to you, if you think it's wrong, maybe you can say why in some sort of simple, reasonable way. You were saying this, and here's why that doesn't make sense to me. It seems wrong, etc. Here's my counter argument. Here's the science that I think directly contradicts you. Here's the refutation by some expert that I think you missed. Here's the book you had to read but didn't. Whatever. Like you can either explain yourself why you think I'm wrong, or you can, use some source that you think needs to be answered and you don't see the answer to from what I've said. And either one's fine, and then progress can be made, and we can take a step forward in the discussion and deal with the issue. And this is the offer I always make and have been making continuously for years and years. And these are the views and opinions I've arrived at by doing this, because no one's ever refuted them. And I've talked to a lot of people. And you might think that I just talked to like casual people on the internet, not real scholars, but that's not true. I've talked with scholars. I've talked with people with various credentials, people who are fancy or prestigious or whatever. I've talked with some of them. A lot of academics, honestly, are not famous, and you can just email them and they reply. The hard people to talk to are the ones who have like, 1 million fans, so they get too much correspondence. But like most like scholarly people, most people who write academic papers are not flooded with inquiries. They don't have that many people that want to talk to them. There's a lot of professors you've never heard of. And if you find one of them and email them, you can just talk to them. Some of them aren't interested and don't want to talk, but some will talk to you a bit and, whatever. Especially if you do things like read their book and say, I have this comment on this passage from your obscure book that no one ever reads. And then people talk to you. But anyways, in addition to that, I have talked to some prestigious, busy people. And on top of that, David Deutsch has talked to more of them. David Deutsch is a published author, a successful author, a member of the Royal Society, an award-winning intellectual, a TED speaker, stuff like that. So he has done things like have dinner with Richard Dawkins and have a conversation. And he's met all kinds of fancy people. He's in the acknowledgments of Steven Pinker's new book. As one of the people who read a full version of the book before release and was commenting and editing and whatever. And he's cited repeatedly in the book. So he has more access than I do to fancy people, and it hasn't made any difference. He has not been able to get them to do paths forward, to actually concede things or answer them. And they say, oh, I'm busy, but it's like, well, has anyone answered it? Because you can just endorse some other answer if there's a good enough one. Either a good enough answer exists or it does not exist. If it does exist, it doesn't matter that you're busy. All you have to do is link it. And if it does not exist, then saying you're busy is not a very good excuse. It's like, okay, you're busy, but no one's ever written a good enough answer. So anyway, if you're interested in that, go to fallibleideas.com and click on the Paths Forward essay. And then there's links at the bottom with more explanation of paths forward and a couple of videos even. But anyways, this stuff has stood up to the biggest tests and public criticism that I've been able to get for it, and which is actually quite a bit. It's not like a severely lacking situation. And I've surveyed the literature and asked a lot of people if there's any literature I'm missing, and so on and so forth. So that doesn't mean I'm right, but, what more can I do? And what more should I do? I think that's reasonable. And that if I'm wrong and people know it, then they're the ones being unreasonable. They should have said so or made better material to explain it, or gotten some of their fans to do more outreach, or, made a good forum where things can be discussed, or whatever. So the ball's in their court now. That's my opinion. And if you disagree with me, the ball's in your court. So I hope you'll say something, do something. Don't just silently ignore me. Don't just be passive about it and say, oh, he must be wrong for some reason. And, think for yourself, and then actually do something and take an interest in, and get more involved and look into it a bit more and actually start evaluating things. And if you don't want to do it with this topic, do it with a different topic. There's plenty of great topics that are important. But do it with something. Think about something. Take some issues seriously and try to really research them and pursue them intellectually and debate them and figure them out. It's the best thing to do with your life. It's the most fun thing and the most important.